Hi, I'm Melissa and welcome to Scopes University. Today we're going to get comfortable using the Infiniium S-Series oscilloscopes and learn some basic setup and triggering tips. Today we're going to learn how to set up the oscilloscope for basic troubleshooting, and then we'll get a little bit more specific by showing you how you can set different triggers to locate defects in your waveform. Along the way, we'll look at cool capabilities of the Infiniium GUI that will help make your life much easier. So let's get started. If you arrive at your test bench to see that your colleague has left some crazy settings on the oscilloscope, a nice way to start fresh is to press Default Setup. Also, if your workbench is really crowded and you don't have a mouse, we can enable the touchscreen by pressing this button on the front panel here. Just as Aaron showed us in episode 1, we can pinch and zoom to change the scale of the waveform on screen. We can also move it up and down, and we can change our trigger level. If we want to have the scope set it up for us, we can either use auto scale on the front panel or we can right click. To right click with touch, you just hold your finger down until the circle appears, and then we'll choose auto scale from this menu. If we had signals on all 4 channels, we can turn on channels 2 through 4 as well. So we'll turn on channels 2, 3, and 4. And we can scale these each separately with their own designated knobs on the front panel. We can also view these waveforms separately in their own grids. So we'll right click, and then we'll choose number of grids, and we'll select 4. And we can drag and drop each of the waveforms to its own separate grid. Now we're ready for viewing our waveforms and doing basic troubleshooting. Next, I want to connect a DUT that hasn't been behaving properly so I can see if I can find out what's going on. So now I have my faulty DUT connected, and we could just hit undo to get rid of this stacked waveform setup that I had, but remember our 2 handy tricks from earlier? We can hit Default Setup and Auto Scale. So we can do that by right-clicking and selecting Default Setup, and then we can right-click again and hit Auto Scale. Or we could have done that from the front panel. Just with these 2 simple steps, we can already see that there's something wrong with my waveform. You can see every once in a while here, there's a small pulse here that occurs that's lower than the other pulses. So first I want to make a voltage peak-to-peak measurement to find out what the voltage is normally on my signal. So we'll come over here and we'll use the quick drag and drop measurements menu. And I want to make a vertical measurement, and I'll grab this voltage peak-to-peak and drop it onto the waveform. That tells me that I'm getting 2.8 volts peak-to-peak on this signal normally. It looks like these runs are maybe only rising up to either 1.8 or 2.3 volts, but it's hard to tell without being able to see them consistently. So let's change that. Auto scale uses a basic edge trigger to stabilize your waveform on screen, but we can choose other events to trigger on as well. Let's go to the trigger menu and select Setup. You can see there are a bunch of different anomalies that we could choose to trigger on in the waveform, but because we're seeing a pulse that's lower in voltage than the rest, let's choose Runt. It looks like a rising edge runt, and the source is channel 1, and we want the low threshold to cross the waveform. So let's set that between -125 millivolts and 375 millivolts. I'll choose 300 millivolts. We want the high threshold to be above the runt, and we said we thought it looked like it was between 1.88 volts and 2.38 volts. So let's just set it for 2.5 to be sure we're above the runt. And it looks like we're capturing those runts. Before I had my trigger set to runt, I couldn't quite tell what the voltage of those runt signals were. So let's go ahead and measure it with markers. We'll turn on markers here, and we want it set to channel 1. And now we can drag my markers to the top and the bottom of my waveform. And now I can see that that runt is about 2 volts peak-to-peak. Now that I've captured the defect in my signal, I'm probably ready to get back to my desk, look at my code, and find out what the root cause is. But I can also save my waveform data so that I don't have to come back to the lab in case there's anything else I want to look at in the waveform data. So let's look how to save it so we can do more analysis offline. I'll go into File, Save, choose Waveform, and I'll save this as .5 runt. And save it, and now it's saved to my desktop on my oscilloscope. Here I'm back at my desktop and I've got Infiniium offline up and running. This gives me the exact same GUI that I had on the oscilloscope on my desktop computer. I want to look at the waveform that we had earlier on the oscilloscope. So I'll go to File, Open, Waveform, and I'll choose Det5Runt and open it. Now I can do all the things that I was doing on my oscilloscope. I can make drag and drop measurements, I can turn on markers, and I can even change time base by using the scroll wheel of my mouse to zoom in and out. I have all the capabilities of the oscilloscope available on my desktop. So we learned how to set up our oscilloscope for basic troubleshooting and how we can use triggers to capture defects and anomalies in our waveform. We can also save that waveform data if we want to do additional analysis offline later. Thanks for joining me, and if you want to see more videos like this, subscribe to our YouTube channel and follow us on Facebook, Instagram, and Twitter.